Next, I want to tell you about saving your workspace. If you are working in R or R Studio, if that's your sort of wrapper for implementing your R GUI, then you might sometimes want to um, save the set of objects that you have access to for some future session. So right now, if I type ls at the console, I'll see a list of the objects that I have. It's actually a vector of the objects that I have, but colloquially I can call it a list. One of them is data 1, that's the data frame that I read in. We have model 2 and model 3. Those are both regression models that I stored. Well, model 3 is an ANOVA model. And S is that vector of trues and falses indicating whether participants are female or not. And I might want to keep those things around for future work, right? This is like saving the entire session, except for the search are remembering what it's searching through, but the rest of the session, so that I can pick up where I left off at some future time. And that's what happens when you do save workspace. If you're in base, the sort of default R installation, then this option will be available in the menu. If you have the console active, if you have a script file active, then you'll have the option to save your script file, which is also important. I strongly encourage you to do most of your work in text files containing code and save those often, so that you have a clear record of what you did. But save workspace would allow me to save this workspace with a particular file name that has the extension rdata. And then later I could open that workspace again using R, and it would still have these 4 objects in it available for me. Sometimes you might have a lot more than 4 objects that you're working with. I don't do this that often, but I do if I have fit some models that take a really long time to fit, because then, of course, I don't want to rerun the code to fit those models. Okay, let's talk a little bit about missing values. I'm going to attach the data frame again. This is the data frame we've just attached. I can see that it's attached by looking in the vector of locations to search. I'm going to look at the age variable. It is this column of the data frame. It's a vector of integers right here. And I'm going to calculate the mean of that variable. That mean is 32. The average age in this sample is 32 years old. Next, I'm going to set one of those values to missing, just to simulate what would happen if we had a missing value in this data set. And I'm going to do it using this subsetting notation. Normally, you're not going to be changing existing values to missing in real life, but this does age bracket 4. Tells R that I want to look at the 4th element in the age vector, and I'm allowed to assign to that 4th element. So I'm assigning this value to that 4th element. Capital N, capital A is a special term in R for a missing value. This is not an arbitrary variable name. Like I could call a variable lowercase na, right? I could call that 3, and that would be fine. But capital N, capital A is the missing value indicator, and it has that special meaning. So now the age variable has still 20 values in it, and they're all integers except for this 3rd one, the 4th one, sorry, which is a missing value now. So if I look at the mean of age now, R is going to tell me that it's missing. Many basic functions in R will return the value NA if any input is NA, and this might seem frustrating at first for simple operations like mean, but it's quite handy because in many cases it is the behavior you want if you're stringing together a lot of functions in a row. But if you want R to tell you the mean of age only considering the non-missing values in age, then you can just add an argument to the mean function call, and that argument is called na.rm, which defaults to false, but you can set it to true for this function call, and it will tell the mean of age only considering the 19 values that are not missing. This stands for remove missing values, or NA remove, or however you want to call it. Other useful functions for dealing with missing values include the is.na function. This one gives me true if the value in the argument is true, and false, or is missing, and false if that value is not missing. So we know the fourth element of age is missing. So is.na of that value gives me true. Most of the time I'm not going to check whether a single value is missing, but I might be interested in knowing which of the values in a vector are missing. So if I supply an entire vector as the argument to is.na, it will give me a vector of trues and falses, where the trues are the ones that were missing in the original vector that was supplied as the argument. This works very similarly to when I used the double equal sign to test which values in a vector were equal to some known value of interest earlier. And so this could be used to do something like tell you how many values are missing in a particular vector. So age is a vector of data, is.na of age is a vector of trues and falses, indicating which ones of those are missing. And sum adds together those trues and falses, treating the trues as 1 and the falses as 0. And so the result of this entire line of code is to tell me that one of the ages is missing. But of course, if you had a data set of 1,000 cases and you wanted to know how many in a particular column were missing, the usefulness of this would become more apparent. Most statistics functions, like LM, automatically perform a complete case analysis. That is, they only consider the cases in your data set that have non-missing values for all of the variables that you're using in the model, which is often the default behavior that you want, in my opinion. And so here I just called a summary of LM of score tilde age with nothing else specified. This will work because data 1 is attached. I attached it over here. And I got a result that has 17 degrees of freedom, 17 error degrees of freedom, residual degrees of freedom, which makes sense because there are 2 terms being estimated, and my data set is 19 and not 20 like it was before, because the case in this data set that has the missing value for age is excluded from the entire model, even though that case has an observation for score. The last thing about missing values that I want to show you is the nan value. So if I try to calculate the square root of -1, 2 things happen. The first is that it gives me a result, which it calls nan, capital A, capital N, lowercase a, capital N, not a number. But it also gives me a warning message telling me that there were nans produced in that operation. That warning message is useful because if I had just calculated the square root of -1 and assigned it to a variable, I wouldn't have seen that the result was nan. X is just storing that value, but I still get the warning message. And so this could be helpful if I'm doing a lot of math on a big data set and I wanted to take the square root of a variable, and I forgot that there's one value in that variable that's negative. I could take the square root of the entire column vector and get this warning message reminding me that I might have done something I did not intend to do. But if I proceed anyway, and I use a data set that contains some nans in it, those will be treated much like regular missing values for most practical purposes. One example is that the is.na function will still return true for values that are not na, but rather nan. So that's also, I think, useful behavior for many real-world situations, because if I was going to fit a statistical model on a vector that included square roots of negative numbers, I might want to just omit those cases for my statistical model, and that would be like treating them as missing values. There are more sophisticated ways of handling missing data in a data set, and I encourage you to ask me about imputation someday if you want to learn more about those or read about it on the internet.